Hello everyone, my name is Miss Shahbazi and I'm so sorry it looked like that it was a technical issue and you couldn't hear my voice. I'm a math teacher for so many years and I taught several times function grade 11. During this time that we have to stay at home, we have to study by ourselves. All of the boards, they send the link that you can study by yourself, but technically the way that we can go in deep and I can teach you, you can learn is going to be much more better for you. Function grade 11 is a function that is a subject and a course that is technically fundamental for advanced function grade 12. For some of you that you want to go to the university and you need the advanced function and the calculus course with the high mark to get a admission for university, it is mandatory to learn very well the function grade 11 and grade 12. You're gonna have so many topics to learn and it's not a time to go back and review whatever that you learn on grade 11 for function. It is very good that you learn very well right now. Make a good fundamental for yourself to go for grade 12. Right now, you are lucky that you have opportunity that you can have a tutor online. OneClass Academy, OneClass Company is offering a 100,000 hours of free tutoring. It's a very good opportunity that you can use on it. And I'm gonna go for the lesson, and during the lesson, I'm gonna give you a website that you can sign up for these free 100,000 hours of the free tutoring. Okay, I'm gonna start with the function and I'm gonna go from this point. But before starting, I want to ask you, please go and sign up for the free tutoring session at this website, JanineTheTutor.com, JANINETHETUTOR.com. It's gonna be a website that you are gonna go and sign up for free tutoring sessions. I hope that all of you can learn from these tutoring and online courses, making sure that you are ready for the next grade. Here, I want just to start with the function, domain and range, and what is the relation and function. The material that I'm going over it, maybe you learn in your regular school, but we are gonna go review it. It's gonna be a good freshing your mind before going for the next topics. And if you have any question that you had it before and you didn't understand very well, it's gonna be a good time for you to make sure that you have an answer for those questions. The first things is that we are gonna learn is a relation and function. Until grade 10, you didn't learn about the function. You learn about the different type of equation and graphs, but they were just a relation for you. Here we are going to talk about the relation and a function. Relation is an identified pattern between two variables. Any two variables that they do have any like a pattern between them, we can name them as a relation that may be represented as a set of order pairs, a table of value, a graph, or an equation. All of these type of showing a relation is a pattern between two variables. Now, some of these variables are sitting in a situations that we can name that relation as a function. A function is a special type of a relation. It is a relation in which each value of the independent variable x is corresponds to exactly one value of the dependent variable y. Here we want also talk about the domain and range. Domain is The set of a data that is talking about all variables that can set in the x value or independent value. The domain is the set of value for the independent variables or x. Most of the time is not a mandatory. We are naming the independent variable as a x. A range is the set of value for the dependent variable y. We are showing a domain as a capital letter domain equal by curly bracket, and whatever that we have, we are going to put in these curly brackets. R is a range. We are using it again, capital letter R equal by, and whatever that is a range, we are going to put between these two curly brackets. Also, I just added here that every function is a relation, but not all of the relations are functions. We know about it. The set notation is used to write a domain and range. Curly brackets are used to denote set of a related data points for values. Inside the curly bracket, we state the number type followed by any restriction. For writing a domain and range, we are going to use these three set of a data or the number set, and we are going to use these symbols. We have a n, capital letter N, as a natural numbers. If the set of a value for my domains are the natural number, I'm going to use a capital letter N with this line on it showing a natural number. Z is a integer numbers. R are the real number. These N, Z, and R, they are very specific ones. We are not writing just as a capital letter N. We are putting a one line over the first part of it to show that this N is representing the natural number. For Z also, for R also. What is the number on a N value? Natural number. All of the positive integer number, 1, 2, 3, 4, and so on. How about Z value? For Z value is all of the negative 0 positive integer numbers. How about R or real numbers? R or real numbers is including all of the numbers that you can think about it. Negative, positive, decimal place, fraction, radical, whatever that you can think about it. All of them are in R real number. Most of the time is not a mandatory again. Most of the time, or is a common one that we use for domain and range is a real number. Now let's go for these symbols. E is an element of. Equal sign with the crossing line, it means that is not equal to. Less than, and there is a line under it, it shows that less than and equal. Bigger than, and there's a line under it, means that greater than or equal to. Less than without any line, and bigger than, greater than. We have a couple of examples here. Domain is X is element of real number. We are reading this one as a X domain is the set of all real number. It's a very common one when there is no restriction for X value. How about here? Domain is X element of R, and X is not equal by 3. We are reading a domain is set of all real number provides that X is not equal by 3. I put example here. You had this example before when you were writing a restriction for rational number. It's like a 2 over x minus 3. Okay. Do you remember you were writing x cannot be 3 because we cannot have a 0 at our denominator? Same thing. Here I can say that x can be all of the real number. For this x, I can plug any number that you can think about it except 3. Then all of the real number can go into this x value except number 3. There's another example here. Is a y, element of real number y is less than equal by negative 7. The range of the set of a real number provided that the y is less than or equal to negative 7. I just put an example for this one as well. Negative x squared minus 7. You learned about this one last year. Negative x squared is an open downward parabola, and because the negative 7 is a 7 steps goes down. Then I have a something shape like that, is a very draft graphing. As you see here, all of the y value, because here we are talking about the range. The range is talking about the y values. Yes? Then all of the y values have a value for less than negative 7. Then I can accept all of the real number, but all of these numbers are going to be less than or equal by negative 7. Now we want to learn about that, how we can say if a relation is a function or it is not a function. For method 1, we are going to talk about the vertical line test. Vertical line test, in a short form we are writing a VLT, is every vertical line intersects the relation at only one point. Then the relation is a function. What is the method 2? Examine that the set of ordered pairs that make up a relation. A relation defined by a set of ordered pairs is a function if for every value of x there is only one value of a y. Then we are going to check that if for each value of x I have just only one value of y. Technically, when we have a graph, the easiest way to find out if it's a function or relation, it's a vertical line test, because visually we can see that if the vertical line is intersecting the function for one point or more than one point. Here there is a two example. I'm gonna go and talk about these two examples. For the next example, I'm gonna give you a time to go over it. As I know, for now it's just a relation, because every graph can be a relation, but I'm not sure if it's a function or not. I'm gonna check if it's a function or not. As you see, it's a parabola open downward. Is a graph look like a parabola open downward going down. When I'm checking this graph based on a vertical line test, I'm drawing a vertical line. As long as this vertical line is just passing in one point, means that this is a function, because this graph is passing a vertical line test. Doesn't matter if I put my vertical line here, if I put the vertical line in any another place, like if I would put here or here, doesn't matter. Each vertical line test would make it just one intersection point. As long as that each vertical line test is passing each vertical line is passing vertical line test, then this is a function. However, for the another example here, relation 2, if I try to check the vertical line test, for every vertical line that I put, I'm gonna have a 2 intersection point. Then this graph is not passing the vertical line test or failing the vertical test. Then this is not a function. It is just a relation. I'm going for domain and range. Domain for this function is gonna be as you see, capital letter D is equal by curly bracket. Okay, I like just know, do I have to put the x element of real number, or x is element of natural number, or z number, like integer number? Let's see here, when I'm checking this graph, I can see that for every point on this graph, like this point, I have a -2 and -4. This coordinate here is a -2 and -4. Then I have a x value as a negative value. Same time here I have a positive value for x. Then I cannot stack on n as a natural number because I have a negative value on my x. Then I cannot use a n. Now I'm checking another point on my graph. Oh, I can see it is a decimal place for x value. Here, if I choose this point, what is the coordinate of this point as you see? Coordinate of this point is -1.5 and like a -2.5. Then technically I have a decimal place. Then I cannot use a z. Then the only set of data that I can use is a R real number. And we talked about it before that, okay, most of the time we are using a R real number. It's a more common one. Then x is element of real number. Next step, is there any restriction or there is no restriction? For restriction, I'm going to check that if there is any value for x that I cannot plug or it doesn't exist in my graph. As you see here, I have a arrow at the end of this graph. Means that x value, like a graph, is continuing to the down. As long as its graph is continuing to the down and also it's going to the left side, then is including all of the x value on the negative side. The other hand of the graph is going to the down this way and is including all of the positive value of the x. Then I can see that I have a lowest value for x here, highest value for x here, and there is no breakdown on the x value. Then x is all real number and there is no restriction for it. I can plug any number that I want into this function and I can find the y value. But when I'm going for range, y is again element of real number because it's including negative value, positive value, decimal place, fraction, and everything. But let's see if there's any restriction for y value. Here, as you see, y value is stopping it here. I do not have any coordinate higher than 1. My graph is hitting y value at 1 and it doesn't go higher than this value. It's stopping at 1. Then y is taking all of the real number, agree, but all of these numbers are less than or equal by 1. Then here I have a restriction for y value. I'm going for the next example. We talked about that is not a function, it is just a relation. Now we are talking about the domain and range. Domain, again, x is all real number because it's including positive decimal places. Yes, it doesn't include negative, but as long as it's including all of the decimal places and everything, I cannot use a n natural number. I have to use a r. Here there is a restriction for x value. X value has a restriction because here, as you see, I do not have any graph here. All of the coordinates on the graphs are having a positive x value. Then x has a restriction, has to be bigger than or equal by 0. How about range? Range is y is element of real number. Range is going to the highest value there, lowest value here. There is no restriction for y value. Then it is a all of the real number. I'm going for second example. Second example, I would like to give you a time to do it, but technically on the last time that when I was doing it, you could see the answer, but still I'm gonna give you a couple of second time that you can go over it, see if you can say this time that if it's a function or not, and what is the domain and range for this function. Okay, go ahead, you have a 20 seconds time. Okay, let's see here. Yes, it is a passing a vertical line test, then it is a function, but the other one doesn't pass vertical line test because it's passing 2 points, then it is not a function, it is just a relation. Domain is all of the real number from negative infinity to positive infinity because there is no restriction on the x-axis, but the range has a restriction between -1 and 1 because the lowest value on a y value is a -1 and the highest value is 1. Here, it's a failing a vertical line test. Domain is gonna be between -1 and 1. As you see, the x value, the biggest value on x that I can say, it's a 1. And here, the lowest value on the x is going to be a -1. Then I am using a double side restriction here between -1 and 1. But for range value, as you see, is going to the high and here going to the low, then is technically is covering all of the real number. Here it was example that I was talking about it, and when I have a pair point, here 4 and 2, 7 and 5, 3 and 1, and 6 and 4, as you see here, it is a function because one value of y for each x. Here my x is 4 and there's just 2. 7, 2, 3, 1, and 6 and 4. For each value of x, I have just one value of the y. Then it is a function. When I'm writing a domain and range is a mistake that sometimes the students are making. Again, they are writing XER, YER. No, here you cannot use the XER or YER. You have to use exactly the points that you have. 4, 7, 3, and 6, they are the only x values that you have on your domain. You have specifically write it down the domain as a x values that you have here. For y also 2, 5, 1, 4 are the values that you have as a range. When we have this type of a domain and range that they are just a couple of integer number, we prefer to write it down in order from smallest to biggest. It's not a mandatory, but it is a more professional to write it down smallest to biggest. And if you have a number coming as a twice, 2 times repeating, we are just writing with 1 time, like a no repetition. How about here? Look at the example 6. 1 and 6, 3 and 9, 7 and 10, and 1 and 4. As you see here, I have a 1 and 6 and 1 and 4. Okay, 1 and 6, 1 and 4, one x value is occurring in with 2 different y value. I have a with 1 and 6 and 1 and 4. It is against the definition of the function. It is not a function because for x equal by 1, I have a y equal by 4 or y equal by 6. Domain is 1, 3, 7. As you see, for domain, I didn't write it down twice, just once. For range, again 4, 6, 9, 10 in order from smallest to biggest. There's another example here. I want just to give you like 20 seconds, see if you can answer it. Relation 7. Okay. As you see, it's highlighted already. You can say that it is a function. Yes, because for each value of x, I have a one value of y. However, this value, all of them are common. We had a restriction for x value. X, for each x, we have to have a one specific y. We didn't have an opposite way. Here, 2, 2, 2, 2, it's totally fine if I have a same value for y. We had a restriction for x as an independent variable. It is a function. Domain is 3, 6, 7, and 9, and range is just number 2. Here, I want to talk about the being a function or not for this circle. Do you remember when you were learning a circle at grade 10? The equation where x squared plus y squared equal by r squared? Here, I want to go over a function, a relation I'm assuming 9. If it's a 9, I can say that here the radius is 3. And if I like to show on this graph that is so neat, it's gonna be 3 here, negative 3 here, 3 here, and negative 3. Let's see if we can write it down, domain and range for this one, and if we can say if it's a function or not. Here, I would like to say it is not a function because it doesn't pass vertical line. Because it's failed the vertical line test. Let's see, doesn't matter if it's a relation or function, we can still write it down, the domain and range. What is the domain here? Do I have a positive value on x value? Yes. Negative? Yes. Do I have a decimal places? Yes. Then I'm gonna use a r. X is element of a real number. Is there any restriction for x value? As I see here, the smallest value that I have for x value is negative 3. I do not have any point behind of this point, and I do not have any like a point or graph after 3. Then there's a restriction for this one between 2 points. X's are between 3 and negative 3. There is this restriction. Let's go for range here. Again, for r or range, I choose to write it down as a real number because I have a negative, I have a positive, I have a decimal places and fractions. Here, I'm gonna go YER. Let's see, is there any restriction for y value or not? Yes, I do not have any graph, point, coordinate lower than negative 3, neither higher than positive 3. Again, I'm gonna have a restriction here. Then, if I like to write it down a function, domain and range for a circle, some things like that, as you see, domain and range, both of them, they do have a restrictions. Here, all the time, we talked about if I have a graph, if I have a coordinate points, now I can guess that which one is a function, which one is not, and so on. Now, do you remember on a definition here? Let me see. Here, I'm so sorry. Do you remember the definition that we had it here? This definition is talking about the order pairs. We talked about it. Table of value is same things. Graph, we talked about it. Now, we want to talk about the equation. If I have an equation, how can I say if it is a function or it is not a function? Here, I want to put an example for you. Here, I have an equation, y equal by negative 3x plus 4. I want to know if it's a function or it is not a function. For knowing if it's a function or not, the best way is to graph. Negative 3x plus 4 is whatever that you learn on grade 9. You can go with y-intercept is a 4 and then rise over 1 negative 3, or you may make a table of value and graph it. Okay, here I'm gonna give you 2 minutes to graph both of these equation. It's a linear, and this one it is a what? A parabola. Okay, draw both of them. Then we are gonna talk after about that if they are a function or they are not a function. Hopefully that you could at least graph like a first one. Let's see. Oh, sorry. Okay, I have a graph here. I'm sure that you have something like that too. It's a 4, is a y-intercept, and I have a slope negative 3, rise over 1, 3 steps going down and 1 step to the right. It's making my second point, and I draw it. Okay, the negative 3x plus 4, it is a line like that. As long as it's a straight line, I know that it's gonna be pass vertical line test, because whatever that I put as a vertical line test is gonna be just a pass at 1 point. Then this is a function. How about domain and range? As you see, it's going to the down here, means that is including all of the x positive value, and it's going that way is including all of the x negative value. Also, because it's going higher than like a going high to the positive infinity and down, I can say that domain and range, both of them are real number, because positive negative decimal place is including, and there is no restriction for none of them, not domain, not range. I'm going for the next example here. 2x minus 2 by power of 2 plus 1. I'm just doing it like a rough graphing here. You can say that's a parabola. The point for this one is gonna be open upward. Then it's gonna be, I'm gonna have a minimum at 2 and 1, 2 and 1. This shape is gonna be, I'm expecting to have a something like that. Is not very like accurate. Here is just a draft sketching, but here I have a better shape, more accurate, that I'm gonna share it with you. Vertex is 2 and 1. It's an open upward. There is a y-intercept at 0. Here I calculated the x-intercept and y-intercept, and there is a x-intercept. There is no x-intercept because the opening upward from this point, it doesn't hit the x-axis. And also I made a table of value 1 and 3, 2, I know that the vertex is 2, is the best way to plug a one number before and one number after the vertex point. Okay, I have these 3 points and it is the shape. Here, when I'm checking a vertical line test, I can see that this is a function. Then this one is a function, and now I like to write it down, domain and range. When I'm going for domain and range here, again is a XER, YER. Now let's see if there's any restriction. Here, X is starting, it can, when it goes up, it can start from very negative number. And when it goes up, it's going to be end up at very positive number at X value. Then there is no restriction for X value. How about Y value? For Y value, as you see, I do not have any coordinates. I do not have any part of a shape for less than 1. All of the values for coordinates are bigger than 1. Then here I'm going to add a restriction. Y is bigger than or equal by 1. Here, there is a next example because I just did exactly same things. X squared plus y squared I did with 9. Now it's a 25. I'm sure that you can do a draft graph very fast. You can write it down if it's a function or not. And what is the domain and range for this one? Good. Then maybe 20 seconds is going to be good for you. Okay. Let's see if you have a same answer. Here is a x squared plus y squared equal by 25 means that the center is 0 and 0 and the radius is 5. Then I can graph a radius as a 5, a circle. As you see, it's failing vertical line test, then it is not a function. And the domain, again, XER, and there's a restriction between -5 and 5. And for Y value, also there's a restriction between -5 and 5. There's another way that we can see if this function has a two values for Y. When I'm checking if it's a function or is it just a relation. Here, look at this function. I had x squared plus y squared is equal by 25. Let me highlight the function, look like that. Okay. X squared plus y squared is equal by 25. Look here how I calculate, or like we did this question to see algebraically if it's a function or not without drawing a graph. Y equal, first I'm trying just to find the equation for y. Here y equal by x squared is moving to another side, making 25 minus x squared. When I'm calculating y, I have to do a square root both sides. Y is gonna be positive, negative square root of 25 minus x squared. Here, as you see, when I'm doing a square root, I have to mention positive and negative. Then for each value of x, if I value x, if for example, if I plug x0, as you see, it's gonna be positive, negative, radical 25. Then I'm gonna have two values for y. One of them as a positive, one of them is gonna be negative. For each value of x, I'm gonna have two values of y. Then this one's also against the definition of the function, is not a function here too. Then for the circle equation, we saw algebraically that it is not a function, and also here we could see on a graph that it is not a function. Okay. Here there is a next example. These examples are just going over the Right now we know the definition function, we know the definition of relation, we know how we can calculate domain and range, but here we are gonna see more questions playing around whatever that we learn until this point. Here there is a functions given a domain, there is a given domain for this function and asking you to calculate or determine the range. Domain for this function is not just this number, but for these specific numbers, we want to know that what's going to be a range. Domain is an input for a function. Range is an output for a function. We like just to know that if we input -2 into this function, what is going to be the range or output for this function? What do you think about it? Here, they are the input. Then I'm going to plug -2 into the function, -1 into the function, 0, 1, and 2. I have a 5 values for x, and I'm looking for 5 values for y's. Then I'm going to plug this number into the function I did already here. Yes, domains are -2, -1, 0, and 1, 2. I'm plugging this number and I'm calculating y value based on whatever that I have. Then for this set of a data of domain, the range is gonna be 8/7, 4/3, 8/5, 2, and 8/3. As you see, the numbers are coming from biggest to smallest. Then when I'm writing, I want to write it down in an order from smallest to biggest. Then it's going to be 8/7, 4/3, 8/5, 2, and 8/3. Hopefully that you like this example. Now I want to go for next example here. Sketch a relation with the following properties. It is a function. Domain is all a real number. Range is y, element of real number, but y has to be less than 5. Then technically x has no restriction, but y has a restriction here. Then I can graph anything that the y value is less than 5. I can easily go and draw a open downward parabola, or I can do any graph that I want. Whatever. As long as, as long as the y value doesn't pass 5. I have a better yes, here, but also I have to make sure it is a function. Then it's a parabola open downward. There's a next example. I'm gonna leave a next example for you, give you couple of minutes, at least 1 minute, that you can do example 1. Next example. You wanna, it is not a function. Be careful. It is not a function. Then you can draw any things that it's failed the vertical line test, and domain is between these ones. Okay, Let's see what did you do. Here I want some things between -3 and 3. And y is between -3 and 3. The easiest one that I could do is a circle. Yep. I could make a circle here. I'm not sure if I can do it properly. Yeah, I do have it here. Then I can show it to you. Yes, it is a circle between -3 and 3, -3 and 3, +3, and as you see, it is failing the vertical line test. You may have any another shape you could have here. You could go that way. Oops. It has to be between 3 and... Oops, sorry. You could do any shape that you like. It doesn't mean that it has to mandatory a circle, but the circle is the best one that we know the equation. Because if I draw some things like that, later on they're gonna ask me, okay, write it down the equation. Then I'm gonna be in a like a hard situation. But if it's a circle, I know very easily I can write it down the equations. Here also, see, if they were asking me a parabola, I could write it down the equation. But here, the red one that I erased it, if they were asking me write it down the equation, for sure it would take me so much time. I want just to like do couple of example. Let's see if I have a graph like that. Uh-oh. If I like, you saw this type of a graph before, yes? Let's see if it's a function or it's not. And if it's like it doesn't matter if it's a function or not, what is the domain and range for this one? What do you think? Is it a function or not? This line, yes, it is a function because it's passing a vertical line test. I'm okay. Okay? Then it is a function. Then I'm okay for being a function. Function, yes. Pass vertical line test. How about the domain? What is the domain of this function? What do you think about the domain? Can I mention x is element of real number? Because, sorry. Because as you see, it's starting from -infinity, going to the +infinity, and there is all of the values on the x. Is there any restriction or not? I assuming that there is no restriction. Then I'm gonna close my curly bracket here. How about range? Range, do I have any positive value? Do I have any negative value for range? The only value that I have for range is number 2. For each value of the x, I have just value number 2 for y value. Then here for range, I'm gonna just write it down. Okay. I can write it down if I like to write it down a little bit. Things I can say just sometimes they are writing y is element of a real number and y is equal by 2, or if you just write it then y is equal by 2 is totally fine. Just that's it. You can write it down that way. It is one of the questions that it was a little bit different. Okay. I want to go for next example. Here, I want to write it down. Or maybe first I can write it down the equation. X equal by, for example, negative 3. Do I know how can I graph this one? I believe so. I know from grade 9. Let's see. X equal by negative 3 is a vertical line. Oops. Drawing a line with these pens is not so easy. Okay. Here, x is equal by negative 3. Okay, I put as much as I could like vertical line. X is equal by negative 3. Now tell me or think about it if it's a function or not. This one, as you could see here, it doesn't pass the vertical line test. Because if I just put a vertical line here on exactly x equal by negative 3, is going to be intersect all of the points. This one, it is not a function. Then this one is not a function because is fail vertical line test. However, still I can write it down, the domain and range. For this one, the only value that I have for range is negative 3. There is no other value. All of the points, they do have it. How about range? But range, there is no restriction. It is starting from negative infinity, continue to positive infinity. There are another two like equations that we have it a little bit special that I talked about it as a linear. But in a total, you can see that you can give an answer for a pair point, for a table of value with checking their x values. From the graph is the easiest way that you can see that if it's a function or relation, or you can write it down domain and range, because you can try vertical line test. You can see that what are the answer for that one. But when it goes for equation, like that, negative 3x plus 4, 2 bracket x minus 2 by power of 2 plus 2, or some things like that, you need to have a graph of the function. Sometimes you need to have a graph of function to say that if it's a function or if it is not a function. Technically, function grade 11 is gonna be teaching you more about the different type of a function and how you can graph them. As long as that you can graph, you can see that if they are a function or not, how you can say that it's a, what is the domain and range. Technically, for the lessons later time, we are gonna see how we can graph different type of a function. We are gonna learn about that, what is the parent of each function, and based on parent of each function, how can I draw the another functions related to the same family, and then what's going to be a domain and range for each of them, how we can transfer a parent to the different type of a function, stretch them, compress them, vertically or horizontally move them. It is gonna be a lessons for the grade 11. Until now we learn about that, what is the domain, what is the range, how we can recognize if it's a relation, it's a function, or it is not a function. I would like to stop here for today's lesson, and my next lesson is gonna be hopefully on Friday. We are gonna go over the different type of a function notation, and how we can go on input and output, and how we can draw some the parent function. I hope that you could use today's lesson and it was useful for you. Stay at home, stay safe, and use your time to improve your knowledge. Practice on whatever that you learn until now. Make sure that you understood them, and make yourself ready to learn new stuff. It's a good time that you can work on your studying, behave, and work with yourself to improve your knowledge. Hoping you the best. Stay at home, stay safe, have a good time, and see you on Friday, same time, hopefully without any technical issues. Thank you. Have a good day. Bye.